Welcome back. So last tutorial, I went over how to animate geonodes with code in UPBGE, and this was the result. I sped it up so you can see it better, right? But basically, we were able to manipulate geonodes by doing this, but you'll notice something that's kind of horrible, right? If I don't use the component, I uncheck is active and I press play. Oh, it's doing some frame optimizations. Let's uncheck that. If it's not moving, the GeoNodes object is getting around, it's partially because of OBS. Basically, it's getting between 400 and 700 FPS, and it looks like it's slowly going down because something's obviously wrong with this code. But I'm going to show you how to optimize the GeoNode animations. So you're going to ask yourself, how can I get the most frames possible? Because again, if I enable this animation, we're getting 70 frames per second. And if you're doing a 2D game where you have a character animation that's 24 frames per second, this probably might not make a difference. But the problem happens when you... I'm going to instance this by pressing Alt-D. If you have more than one object, see, now we have 3 on screen. Our FPS drops to 32 frames per second. Let's add some more, right? Now, they are being calculated with delta time, so their speed's not being affected. But, see, now we're down to 21. Now we have 5 of them, right? So, that means we basically have to limit the number of items in cameras, number of GeoNode objects in camera at a time, right, for optimization. And you might ask yourself, is there a better way? And the answer is yes. So we're going to do that now. So if we bring up our old code, close my terminal. One sec. Yes, I made my own. I made my own TUI for Blender. All right. If we load the old code, you'll see we're basically animating the anim scalar node in the node tree using Python, right? The problem is that you'll see when we play this animation, the source of all the slowness is coming from Blender's dependency graph, which is where it says DEPS graph here on the screen. It's at 91% and 42 milliseconds. So that's the source of our slowdown. You'll see the rasterizer's only, going 3 milliseconds, which is kind of high, but not bad. And then the GPU is not getting anything. So the GPU is able to, power through this without a problem. But the dependency graph in Blender, we're having a bottleneck probably between the processor and the GPU. So is there a way we can speed this up by caching that data somewhere? And the answer is yes. And we're going to do it right now. So first, let's go ahead and delete these other instances. Move this one back. And I don't know why this thing turned bright white on me. It happened when I duplicated the instance. Might be a bug. So we're just going to revert this save file. There we go. And we'll get rid of these scripts. So right now we have no Python attached. We'll get rid of our component. And what we're going to do is we're going to go ahead and animate this. So we're going to move our text editor down here. And we're going to go to first the GeoNodes editor. Let me clear my keyframes here. Let's bring up our dope sheet. Our action editor. Let's clear out all the actions. All right. There we go. Okay, so all the keyframes are cleared. We're going to get this back down to 0. Okay. So you could watch the last tutorial on GeoNodes, but basically this atom scalar node is the controller for the motion. The C node changes the shape of it, right? So we have different shapes we can choose from. Right. So we'll get the C back to the one I like. Let's go ahead and fix the color a little bit, make it dial down the strength here. And let's go ahead and make it orange. That looks cooler. There we go. All right, so we're going to create our animation. So first we have to go to the dope sheet, select our object, and in the timeline we're going to go to frame 1. And then we're going to, in our node editor, we're going to, in our anim scaler, we're going to go to factor, mouse over the value, and press I to keyframe. It's yellow, so that created a keyframe. If I go to summary, we don't have anything yet, but we will. Then the max value of our animation here is 250, so we're going to go to frame 125 and go 0.25, because that was the other cool shape it's going between. And we'll mouse over, press I. That sets the keyframe. And then we're going to go to frame. Frame 250. Set it back to 0, so we have our ping pong animation. Mouse over, press I. Then when we scroll across our dope sheet, we have our animation, right? Then also, if I press play in here, yeah, we're going between 5 and 700. Part of that is because OBS is processing right now. So like if I turned off OBS, I was getting 1,000 frames per second. So, we could either play this animation, and that's going to drop our frames from like 700 frames per second to 250, which is still a severe drop, but it's manageable. And then you could like do other optimization, like, you know, only allowing one geo node per, you know, in camera at a time in your game design, right? But the better way is to actually, now that the animation is set, we're going to bake it to the scene data. So if I go to our node tree here, let's get this out of the way. So we have all these nodes, right, that are doing something with a volume set, right? With a volume, part of the reason the dependency graph is going crazy is because this is based on a volume cube. So it's basically like manipulating a cloud, like a procedurally generated cloud texture in addition to everything else, and mapping it to a spear shape before it assigns the geometry mesh. So what we can do is we could pre-process all this by using the bake node. So in our geometry nodes, that if we go Shift A and search for bake, you can grab the bake node and plug it in here and put it in there and set to animation. And then we can choose bake. Now, if you go to your modifiers section here, modifiers tab, under the bake section, you can choose either packed or disk. Packed will basically store all the vertice data that's output from the geometry nodes into the blend file. So your blend file will get really big, which is actually probably what we want. So the player, so you know, someone playing your game can't go and hack around in this, right? The other option is disk, and when you use disk, to the directory that it's indicating, it's going to basically write every vertex as a JSON file. Every vertex and face data in here to a JSON file in a folder. And that could get a little, I mean, it's still the same size of data, it's only text, but then like it creates opportunity for people to hack your game and stuff. So we're going to choose packed. Also, I think it compresses it so it might read faster. And then, so we click the animation button and we click on bake. It says baking nodes, progress bar goes and it's done. So what this means, I should bring that back up. Bring this back up. Okay. So what this means is we could actually just increment the scene data. So what we'll do is we're gonna import the scene. So self.scene is equal to bge.logic.get current scene .name. And then we need an incrementer. So we'll do self.incr is equal to 1. Then we'll do bpy dot data dot scenes self.scene is equal to, oh, let's go back to Blender. Frame current is equal to self.anchor. And then we'll increase the incrementer. Because update is our while loop, so after it sets the frame of the scene, it'll increase the incrementer and then update the scene, right? Then we'll do if self.anchor is equal to greater than or equal to 249. Self.anchor is equal to 1. So this will make the it loop through the frames of the scene, right? And that should be it. See if we have any errors. No errors right now. And if we press play, whoa, look at it go. So our animation's running at 500 frames per second right now, so way better. So what if we need to slow this down? Well, this is where delta time comes in again, right? So we could do bring in our delta time function. Target FPS is equal to get our logic tick rate. Our average FPS is equal to get average frame rate. Return target frame rate over average frame rate if 0 is less than average frame rate and average frame rate is less than 10,000, else return 1. There we go. And then we'll set dt equal to delta time. And then incrementer will be plus times dt. We'll save it. We'll reload it. And nothing's happening. Am I getting an error? Oh. So we got to cast this to an int. There we go. There we go. Slow down a little, but it's looking smoother. So what we're going to do is we're going to actually move this here. Because we still want this to stay as an integer while it's cycling, because if we want to control the speed of this animation, we have to create we have to use a prime number to slow it down. So we'll create a variable called slower. No, we don't even need to do that. We'll just hard code it in. So we're going to move this to the bottom of our code here. Something's off with our tabbing. Yeah. There we go. And we'll do self.anchor plus equal 1. And then go ahead and move this in a bit up. Here we'll do if self.anchor modulus 5 is equal to 0. So every time the incrementer is increased, is divisible by 5, then it will execute this code. No, we got to create a variable called slower, so we'll do that. Let's move this back. we've done that. I don't think we care about delta time right now. Okay. So we gotta do self.slower is equal to 0. And we'll do if self.slower what did I do wrong? Oh, I had some extra characters in there. Okay. All right. So if the modulus of self.slower, and then there you go. So every update, every frame, slower is going to go up by 1, but every 5 frames, increment is going to go up by 1, and that'll slow down our frame rate. So now if we play this, it's a little bit slower, but still not quite. So let's do it a lot more than that. But you see we're getting great frame rates, right? We're getting 589, between 540 and 580 frames per second. So let's go ahead and as we slow it down even more, because the dependency graph has to update less often, if you slow down the animation, it's actually going to improve the performance. So we'll try doing another prime number like 23. And then yeah, see how smooth that is? Still going at 580 frames per second. Could put a cool sound effect with it, right? Like, right? Like, or like, okay, never mind. All right. The ping pong's kind of noticeable, so we could slow it down even more by increasing the prime number, right? So the next big prime number I could think of, I think, is 59. It's starting to look a little choppy. But it's still holding at 580 frames a second. And you notice it's doing what it's supposed to now. See, the dependency graph is not going above 1%, and the rasterizer's and the GPU is doing all the work now. So if you're doing this in Vulkan, it would shift more of the GPU, but then you'd be capped at 60 frames per second. But you know, that's cool too. We can go ahead and try and multiply this by delta time. If the frame assignment allows floats, so... Oh, we're going to cast it anyway. Okay, so Control C. C. And then we'll do... Right. See, that smooths it out. Yeah, it's moving really slow now. And doing some shakiness. Because the delta time anchor, the anchor times delta time is, yeah, making it go back and forth. So we have to increase the, we have to lower our prime number now. We're using delta time, so we'll make it 5 again. Or we could try 19 or 17. That's a good prime number. See what this does. Oops. Well, that'd be cool for an unstable animation effect, but okay. No delta time on this. Not at all. Let's just go ahead and... Okay. There we go. That's nice and smooth. All right. That's fine. Getting 500. Yep. So we could go ahead and increase it some more, though, to increase our optimization. So I think we're going to be good with like 29. So make our prime number 29. Reload it. There we go. That's nice and smooth. Yeah. Yep, that doesn't look like we mind if it ping pongs. Okay. Nice and magical. Still at 560 frames. And now if we go ahead and, the other cool thing though is because we can go ahead and duplicate this a bunch of times. Right. And on these extra ones though, we're going to remove the component because we don't need these fighting over the frame number, right? We only need one component changing the scene's frame number. Now when we play it, they're all going. Look, even our frame rates are improved slightly, right? That's because we increased that prime number up. Oh yeah. Because there's more on the screen that we're getting more variation. So yeah, it looks like we're holding between 480 and 600 frames a second with this. So that means you could put a few, you could put like 5 of these or 10 of these in a scene. And if we slow it down even more, the performance should improve. So you'll give the dependency graph more time. So what's another? Is 37 a prime number? I think so. The other thing we should do, though, is we should after all this, if self.slower is equal to 38 greater than or equal to 38, self.slower is equal to 1. So that way, in Python, as you add more digits to an incrementer, as the longer the code goes, it's going to effectively slow it down because Python will keep casting that integer as it gets bigger and bigger. It'll start as a integer, and then it'll expand from 24 bits to or 28 bits to 32 bits. Then it'll expand to 64 bits after it gets big enough. Right, it'll switch from becoming an integer to a double in memory anyway, and so and then at some point it starts assigning multiple memory addresses to that number to make for all the extra digits and stuff. And so when it gets past 37, and it hits 38, that's the same as 1. So we'll make it sign to 1, so it never gets bigger than a 32-bit digit, so, or even a 16-bit digit. And then go ahead and try and play this. There we go. Yeah, we now have 630 frames per second. And it's bottoming out at 490. So now you can add ambiance to your games with geometry nodes. So we'll do a quick review. So first in Blender, you go to your geometry nodes. And you add a node to the end of your tree, the bake node. And it's going to, then you set whether you want it to animation or still. You click on bake. The progress bar will come up. It'll bake the animation into the scene data. If you go to your modifier under manage and bake, you could either make it packed, which stores it in the blend file, or you can go disk and type in a browse to a folder to save all the data to. If you have a solid state drive or an M.2 drive, disk might give you more performance because it'll be reading through the PCIe bus of the computer instead of having the file read. I mean, same with the blend file's on the hard drive too, so it doesn't make a difference. But packed stores it in the blend file, so your blend file gets bigger, and then disk stores it as a folder of JSON files. Once you have it baked, you can scroll on your timeline. And you'll see the animation. And then you go to the script, and you create this script. So you get the scene name, a variable for scene name, an incrementer variable, and a slowdown variable. And then you can set the slowdown to a prime number, so it only increments so the incrementer only goes up like once every certain number of frames, right? And then you can, once the incrementer hits 249, it goes back to 1, so that animation loops. The slower increments up when that slower hits 38 after it's hit the modulus to equal 0. It'll flip it back to 1, so it loops the slowdown. And that's how you have it. You basically change the scene frame. Now the problem with this is if you have other animation, right, in your game in the scene, right, that animation, like on your characters and stuff, is going to get wonky because the scene frame will be changing, right? Now theoretically, the actions in BGE are tied to your object, so it may not make a difference. But if you find that when you're doing this with geometry nodes and your player, right, starts having jittery animation, you may have to you could try importing like one scene into another, so that scene has its own. Well, yeah, I guess you could assign each. You could try multiple scenes. Do a new scene. I don't know. Anyway, that's how you animate geometry nodes so it's fast and doesn't slow down your system. You bake the geometry you bake the geometry tree with the bake node, and then in your code you increment your current frame in your scene under BPY data scenes. All right, that's it. Let's make this thing look cool here. Let's unlink its material, change color of this one. Oh. I guess if I change the material. Oh. Oh, that's because I did Alt D, huh? If I did Shift D. Hmm. Oh, I'd probably have to bake it again. So let's bake this node tree. There we go. Let's change its color. There. And there you go. Look at the glory of the geometry nodes. Anyway, that's how you do it. Have a great day. Bye.